Hello, this is Mr. Henry, and welcome to lesson 4.5, Real-World Problems, or we should call it problem solving. Not all of them are real-world problems. So the such question says, how do I use linear equations to solve real-world type problems? This is the last lesson of this unit, by the way, so just make sure you've understood all the concepts leading up to this. If there's lessons that you've struggled with, or if there's particular problems in here that you're struggling with, these problems that we're looking at today are all applications of what we've already done in the previous 4 lessons. So you might need to go back to those previous lessons to pick up some misunderstandings, possibly. Did you know that linear equations and graphs are great ways to represent something that moves or grows at a constant rate? Things like a printer printing pages, chocolate factory making chocolate bars, or even a car with its cruise control on. Each of these things, the rate or the speed that it's working of the machine is the slope of the line. So if you would graph the graph of a car driving down the road at a constant rate, it would be a straight line. The Y-intercept would be the initial value, or the amount of the job that has already been done. So if you have some chocolate bars already made and the machine's making more, this would show how many chocolate bars there are over time. It starts out with this many and it's making more, so after, let's say, 5 hours, there's now this many chocolate bars. An example: if you're traveling home and you've already traveled 40 miles and you're traveling home at 55 miles per hour, then the equation 55x plus 40 could be used to find how long it would take you to go y miles. And you could always plug in a number in for x, and we could see how long, like after, say, 3 hours, how far have you traveled? 55 times 3 plus 40 would give you that distance that you've traveled. Okay. There is no new vocabulary for this lesson. Yay. Problem 1. A linear function is represented by the equation y equals 12x plus 8. What is the difference? Difference means subtract. What is the difference between the y values of the function at 2 consecutive x integer values? That's a lot of words thrown in there. So let's break down what that means. Okay, so here's what I'm looking at. The idea of 2 consecutive x integer values. What that means is if I have an xy table and I have 2 numbers, consecutive means right in a row. So if I go like 1, 2, 3, 4, there are 4 consecutive numbers. It's only looking for 2 of them. What is the difference between the y values of the function at 2 consecutive x integer values? So I need to find out what are these y values, and then I want to find the difference of them, which means I'm going to subtract. Okay, so now I have my game plan. I read the problem, I interpreted what it meant, and I put some thoughts down here to make sense of it all, and now we do. So I'm going to take my equation, y equals 12x plus 8, and I'm going to plug in, well, these 2 values, obviously one at a time, and find out what my y value is. So if I plug in, say, well, the first one is 1 for x. 12 times 1 plus 8. Y equals 12 times 1 is 12, plus 8 gives me 20. Okay, and I erase. And I do again. This time, I'll be plugging in 2. 12 times 2 plus 8. 12 times 2 is 24, plus 8. 24 plus 8 is 32. Now, I could do more of these. I don't really need to, but I could. So we found the y values of the function at 2 consecutive integers. That's what we found so far. We found all of this second half. So now we have to find out what is the difference between them. So if I subtract them, 32 minus 20 gives me 12. The difference is 12. And by the way, it's not a coincidence that that is the slope. The slope of the line is going to be the difference between the y variables when this guy is following a pattern. So if I go 1, 2, 3, 4, 5, each of these is going to go up by 12, up by 12, up by 12, up by 12. That is what the slope means it's going to do. Every time the x variable goes up by 1, the y variable is going to go up by 12. The slope is 12 over 1. Y variable over x variable. As the x variable goes up by 1, the y variable goes up by 12. Okay? So there's a couple different thought processes you could go through to answer the question. I made a little a table here. You could also use the idea of slope to do it. Either way, the difference between the two consecutive variables is 12. So, example B says, Kevin delivers groceries to people's homes. He charges a fixed rate per mile and a fixed delivery fee. When Kevin makes a 10-mile trip to deliver some of his groceries, he charges $11. When he makes a 5-mile trip to deliver groceries, he charges $8.25. What equation could be used to determine the amount of money that Kevin will charge when he makes these trips? Okay. Now, this is a fairly difficult problem. Okay, so don't be upset if you're looking at this and you're not able to get it. This takes some problem solving. Now, to find, if I'm thinking of this equation, I'm thinking of like this y equals mx plus b thing. I'm thinking of this slope-intercept form. Now, in the situation they gave me, this b would be that fixed delivery fee. This m would be his cost per mile, the slope. Okay, and then the x, it says x is the number of miles. And then the y, it says is your cost in dollars. Okay, that is what is going on here. So we have a fixed delivery fee, and we have how much does he charge per mile. So every mile you go, this would start to increase. Now, in order for me to find this cost per mile, I need a little bit more information, or I should say, I need to pull some information from the problem. Here's the problem tells me. It tells me that when he went 10 miles, he charged $11. And when he went 5 miles, he charged $8.25, right? 5 miles, $8.25. And what we have here is we have 2 points on this equation. I know that when he charged this much, when he went that far, he charged this much. When he went that far, he charged this much. I have 2 points on this equation, on this line. If you're imagining, we've talked about how lines and equations show the same thing. We have this line. It's giving me this point here and this point here. I can take that information and I can actually find the slope. This cost per mile. I can find the slope, and once I know the slope, I can find the y-intercept. It doesn't look like it at first. This seems like a pretty hard problem. Okay? Now check this out. If I find slope here, which, if you know what I'm talking about now, if you wanted to pause the video and you want to try this out on your own, go for it. See how far you can do without my help now. I bet you can do it. But if not, check this out. Slope. We know slope is y2 minus y1 over x2 minus x1. x1, y1, x2, y2. So I'm going to take $8.25 minus 11 over 5 minus 10. And I subtract, and that gives me a negative 5 down below, and 8.25 minus 11 up top gives me negative 2.75. 75, right? Yes. Now, Negative over negative. I don't like that. And actually, since we're talking about money, does your money look like that? When you go to the store, do they have prices that say, I want negative $2.75 over $5? No. So let's divide this. Let's turn this into a decimal. So I'm going to take negative 2.75, divide negative 5 equals 0.55. That is my slope. My slope in this equation is 0.55. I have now found one of the pieces I need. I have slope. Now, if I can find my y-intercept, I'm done. So I'm going to take this chunk. I'm going to move this all off to the side. Not you. All of this. Group U. I'm going to label you slope. That's what I found. I found my slope. Now, I need to find my y-intercept. So here's my work for finding the y-intercept. I'm going to take this equation. Y equals 0.55x plus b. And I hope you remember doing this before. If we want to find the y-intercept, we have to plug in a point for our x and our y variable. I know some x and y variables. They give me 2. Here they are. See them? I'm going to take the one that's prettier. I'm going to take this one because there's no decimals. So I'm plugging in 11 for my y and 10 for my x. 11 for y, 10 for x, and if I solve this equation, I find b. Well, so I multiply. Superstar, I can multiply in my head. Ba-boom. And I solve. Subtract 5.5 on both sides. And I get b is equal to 5.5. So I have now the equation of the line that goes through those 2 points. Now, proof. Desmos. I had the equation y equals 0.55x plus 5.5. Now, does this go through the points? What was it? It was 5 miles and 8.75? Or 8.25? Was it? Where is it? 825. How about this? 8.25. Hey, look at that. My point's right on the line. Sure, you can show it. And it went through the point 10, 11. And sure, you can show that. Where is point 10, 11? Look at that. So what they gave us, it looked really hard. They gave us enough information that said, hey, here are 2 points on my line. You've given me cost and you've given me miles. And that's the 2 pieces I needed. Doesn't that look almost exactly like what I just had there on Desmos? Look at that. Huh? And so we took that. We found the slope of it doing our slope formula. Boom, boom, boom. Once I knew my slope, I plugged my slope in. And we found the y-intercept by taking one of our points, I used this top one, and plugging in for x and y. And when I solved, I got my equation. And I just proved to you, using Desmos, that those 2 points are on that line. That this line, this equation we came up with here in Desmos. Oh, my cursor doesn't show up in Desmos. Interesting. But the equation I came up with here in Desmos is the correct equation. Okay? Seemed really hard. Not as bad as I originally thought it was. Letter C. The graph below shows that the rate of haircuts given at a barbershop through the day is 11 haircuts every 4 hours. Another barber is hired, and the number of haircuts is increased by 1 every 4 hours. What is the slope of the line after the new barber is hired? So you have the little graph on your paper. You have the information I have here. I want you to see if you can solve this. And by the way, the graph is showing the original stuff. 11 haircuts in 4 hours. I can go 4 hours and I can see that's 11 haircuts. Okay? Your job is to figure out what would be the slope of the line after the new barber is hired. Pause the video, try that on your own. When you are ready to continue, hit play, and we will go through it together. Okay, so this is a lot easier than you probably made it out to be. It says they do 11 haircuts in 4 hours. They hired a dude, and it increased by 1 every 4 hours. So if you just add 1 more haircut in those 4 hours, what's that give you? Well, that gives you 11 plus 1 makes 12 haircuts in 4 hours. So then the slope of this line is this, but as a fraction. Look, haircuts is your y variable, hours is your x variable. So I'm going to go 12 haircuts in 4 hours. Simplify a teensy bit. 3 over 1. 3 haircuts in 1 hour. That would be the slope of the line. So instead of my line going through right there, 11 haircuts in 4 hours, if it increases by 1, it goes right through there. In 4 hours, there'd be 12 haircuts. In 4 more hours, there'd be 24 haircuts. In 4 more hours, there'd be 36 haircuts. It's going up by 1. Okay? Every 1 hour, you got 3 haircuts. And that was it. Okay? Understanding that the haircuts per hour is the rate. It is the rate of haircuts. It is the slope of haircuts. So if your slope was 11 over 4, and you increase it by 1, then it's now 12 over 4. 12 haircuts in 4 hours instead of 11. Letter D. Write an equation of the line that has a slope of 3 and a y-intercept of -2. Very easy. This is one that we're supposed to do together, but I want you to see if you can do it first. Dig back in your brain. Can you write the equation of this line that has a slope of 3 and a y-intercept of 2? Pause the video or write quickly. I'm going to write slowly. Y equals 3x minus 2. Because that guy right there is my slope, and that guy, ooh, I missed him. That guy right there is my y-intercept, because this is the equation in slope-intercept form. Okay? So the equation of the line that has a slope of 3 and a y-intercept of -2 is y equals 3x minus 2. Slope, intercept. Letter E. A little bit harder for you. What is an equation of the line that passes through the points 3, -3 and -3, -3? Okay, so I would like you to pause the video and do this on your own right now. I can think of a couple different ways of doing this problem. You just have to come up with one. But I challenge you to think of maybe more than one. Go ahead. Okay, so you might have thought of, if you looked somewhere and found some graph paper, or if you made your own graph paper, and we only need a couple little lines. even if it's ugly. So here is my axis, here's my axis. And you could go, okay, 1, 2, 3, 1, 2, 3, and 1. So that was the first point. This is the point 3, negative 3. Second one is the point negative 3, negative 3. And you're supposed to find the slope of that line. Well, the slope would be up 0 over 1, 2, 3, 4, 5, 6, which is 0. There's a slope of 0. That line would be a horizontal flat line. Look at it. It's going right across this guy right here. That is way number 1. You can use a picture. You can draw it out. Way number 2. You can use your formula. We have a slope formula. You could use the slope formula. M equals y2 minus y... Oh. I need an equation. Oh, I found the slope. I didn't find the equation. So the equation would be... So if that's my slope and my intercept, well, if you're a line going right through here, and you're crossing through right there, my equation would be y equals 0x minus 3. Slope is 0. It's crossing at negative 3. And then, since this is useless, when I simplify, I get just that. So there's my equation. Now, the other way is what I was doing up here a second ago. So if I plug in my points, I've got x1, y1, x2, y2, negative 3 minus negative 3 over negative 3 minus 3, and negative 3 minus negative 3 is 0. Negative 3 minus 3 is negative 9, which, fine. 0 divided by negative 9 is still 0. So then, in my equation, y equals mx plus b. This is, by the way, very, very similar to what we did in this problem. I found my slope. I'm going to plug my slope in with 1 point in for x and y. I plugged my slope in with one of my points. I'm going to pick this guy. So I'm going to use 3 for x, negative 3 for y. And let's see what that gives me. 0 times 3 is 0, plus b, and negative 3. So I have, well, I don't really need to subtract 0. This isn't really doing anything for me. Just b equals negative 3. So now I have my slope. I have my y-intercept. And if I put them together into my equation, I get y equals 0x minus 3, which again, I don't really need the 0x, so we just call it y equals negative 3. So we got our picture way, we got our equation way. They both work. It's just problem solving. You find the way that works best for you, and do it. Letter F. The graph below shows the relationship between the number of minutes Ray walks and the number of calories he burns. Okay. What equation could be used to find the number of calories Ray burns when he walks for X minutes? So we're looking for an equation for the number of calories he burns when he walks for X minutes. So when I'm thinking of the equation of a line, I'm coming straight to this. This is the equation that pops in my head. So I need two things. I need my slopes. I need my y-intercept. Looking at the pretty picture, I can get both of those things very quickly. First off, my y-intercept is 0. I can see the lines crossing right here at the origin. So my y-intercept is 0, which kind of makes sense because if this guy Ray is walking for 0 minutes, how many calories is he burning? None. He hasn't started walking, so he's not burning any calories. Okay? So, origin. That's my y-intercept. Slope. Well, I find a couple points on my line. Boom, 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 boom. There's also one down here at the origin. I'm going to count my boxes. And I'm going to pay attention to my units, my scales on the side. Oops, I'm just going to pretty him up a little bit. So from here, I went from 4 up to 8. So I went up 4 units, and I went over from 1 to 2. I went over 1 unit. So I went up 4 over 1. Up 4 over 1. Slope, 4 over 1. This is my slope. So if I simplify this equation, I don't need to have a plus 0. I don't need to have an over 1. If we simplify, it looks like y equals 4x. I'm just getting rid of the useless junk. I don't need to have a plus 0. I don't need to have an over 1. Y equals 4x is the equation that represents how many calories Ray would burn after walking for X minutes. And if you're saying this another way, he's burning 4 calories per minute. The Y variable is calories. The X variable is minutes. So every 1 minute he walks, he burns 4 calories. And if he walks for 0 minutes, he burns no calories. Letter G. This one's for you. It says, what is the equation of the line that passes through the point 3, -1 and has a slope of 2? Go ahead and pause the video. See if you can work that out. When you're ready to continue, hit play, and we'll go through it together. Okay. So, equation of line. I'm going slope-intercept form. Slope-intercept. It tells me my slope is 2. That's less work I have to do. Now, if I had my y-intercept, if I knew this piece right here, I would be done. But I don't. The other piece of information they give me is a point. Like we did here, and we did here. After I have my slope plugged in, I'm going to plug in one of my points in for the x and y variables. The point they give me has an x value of 3 and a y value of -1. So if I do this math and solve, this will find my only variable left over. It will find my y-intercept. So if I multiply, and I subtract, and I do -1 minus 6 is -7, I got a y-intercept, I got a slope. So the equation of my line, if I plug everything back in here, my slope, it said, was 2. The y-intercept that I found was -7. So the equation is y equals 2x minus 7. I plugged in slope and a point. I found my y-intercept, and then I just plug it in to get my final answer. Y-intercept from there, slope from there, and we're all good. Got 2 left. Letter H. Camilla was filling a barrel with sand. She poured the new sand through a funnel and into the barrel at a constant rate. There's that word again. Rate. Constant rate. Slope. And the fact that it's a constant rate means it's linear. Means it's a straight line. The barrel already has some sand in it. That is your initial value, which is your y-intercept. Since she used the graph below to mark the volume in cubic feet of sand in the barrel at different times after she began filling the barrel. Okay, so we have a graph that she gave us that has some of this information in it. Question is, what equation represents the volume in cubic feet of sand after X minutes? So, what is the equation of the line? So, why don't you go ahead, pause the video, do this on your own. When you are ready to continue, hit play, and we will go through it together. All right. So from my pretty picture, I'm writing the equation of a line. So there's my y equals mx plus b. That is my slope. That is my y-intercept. And looking at my pretty picture, if I would take a straight edge or a ruler or something, and I'm going to sketch right through here. Boom, 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 boom. My y-intercept is 5. That's where this line is going to cross the y-axis. It's crossing at 5. I can see it right there. If I would erase my red dots I did, the pattern is up 1 over 2, up 1 over 2, up 1 over 2. So the reverse would be down 1 over 2 the other way. Still 5. Okay? So y equals something x plus 5. Now, if I can find my slope from the pretty picture, I'm done. So let me erase again. Let's see. Slope. Well, I was giving you the boxes. I said up 1 over 2 boxes. What we got to check for is to make sure that one box that we're going up is actually 1 unit. Because when you're counting boxes, you really have to pay attention to the scales on the x and y axis, because sometimes that can screw you up. So I went from 6 up to 7. How many units was that? Well, that was 1 unit. So my slope is going to be up 1. When I went over from here to here, how far over did I go? It's 2 boxes, but how many units? Well, it's 2. We went from 2 to 4. So my slope is just up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Equation of line. I found the slope from the pretty picture. I found the y-intercept from the pretty picture. I wrote the equation of my line. Letter I. Willa repairs lawnmowers. She charges $20 to identify the problem and $15 per hour. This per hour thingy, that's her rate. That's her slope. She uses the equation y equals 15. See, there it is. There's that slope again. I told you. Y equals 15x plus 20 to determine the total price in dollars for a lawnmower that takes X hours to repair. Okay, so she uses this equation to figure out how much it costs to repair a lawnmower. Which graph represents the relationship between the total price in dollars and the number of hours it takes? So which graph below shows that thing? Okay, so I'm going to write it down here so I can get both things on the screen at one time. So what I'm looking for in my graphs is I'm looking for something, first off, that has a y-intercept of 20. Because that's very easy, usually, to see if it's right or wrong. So if I got my 4 choices, y-intercept is 0, y-intercept is 20, is 0, is 20. So I know it cannot be letter C and it cannot be letter A because they have the wrong y-intercepts. Can I? Haha. Science. All right. So I'm eliminating choices. I've eliminated 2 already. Now, between these 2, they both have the same y-intercept. So now what matters is their slopes. Which one has a slope of 15? So I'm just taking a look to see if there's anything that stands out. Not really. So I'm going to have to start coming up with some points. And if I'm looking at it, these don't exactly go through any of those lattice points. They don't go through any of those, like those crisscrosses. Like no, 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 no. None of them do on either of the graphs. So I'm going to have to do a little bit of estimation. So I know this point right here is the point 0, 20. Okay? And that's true for both of them. That's the y-intercept. So if I can just get like one more point, I can make a good estimation. So I'm going to pick, I'm going to pick this guy right here. I'm going to say that's the point 2, 55. That looks like it might be like 55. It's pretty darn close to 60. So I just picked a nice pretty number, a little bit less than 60 is what I did. Over here, none of them really look that great. So I'm going to pick this guy here. And that's 2. Well, if this is 55, that's smaller. So like 50? I don't think 45. Let's go with 50. I know it's less than 55. It has to be less than whatever I said here. So let's see here. If I find the slope here, so y2 minus... Oh, wait, what am I doing? I'm supposed to be... This is my x1, y1, x2, y2. So my formula, that's what I started right here, y2 minus y1 over x2 minus x1. If I plug in my numbers, 55 minus 20 over 2 minus 0 gives me 35 over 2, which is 17.5. 35 divided by 2. Okay, that's pretty close. That's pretty close to 15. I mean, I'm estimating, right? So I could be off by a little bit. Now, I don't want to just right away go through and say that's my answer because, you know, maybe it's not. But it's pretty close. So now, let's do the same thing with him. So x1, y1, x2, y2. Formula is y2 minus y1 over x2 minus x1. That is our slope formula. If I plug in y2 minus y1 over x2 minus x1, that gives me 30 over 2. Okay, that makes sense. It's a little bit smaller. And 30 divided by 2 is 15. So my estimation gave me this one is exactly 15. This one was a little bit too high. So out of these two graphs, this is the one that had the right y-intercept and the right slope. And if you did not estimate exactly 50 like I did, let's say you did, well, 45 wouldn't make sense. Here's why I'm saying 45 wouldn't make sense. Because 45 is halfway between 30 and 60, so 45 would be like here. And it's a little bit higher than 45. So if you said like 47 or 48 or 49, honestly, you're still going to get a slope that's closer to 15 than 17.5. Okay, if you said 51 or 52 or 53, it's still going to be closer to 15 than 17.5. And if you didn't use that point, you picked another point. You picked that one. Well, you're going to have the same predicament. That's what? 4 and... It's not 90. 80, maybe? So if you used 4 and 80, you're still going to get the slope of 15. Okay? So that's why the answer is letter D. We found the graph that had the correct y-intercept and the correct slope. Now, disclaimer. What if you did both slopes and you got 15 for both of them? Your estimation was off somewhere and you got 15 for both. Well, clearly you made a mistake. You can't have two right answers. So you'd go back and look for mistakes. You looked. You can't find a mistake. What do? Well, the good news is, by us crossing off two wrong choices, we've already narrowed down our chance at guessing the right answer is 50-50. That's better than it was. So at least, if nothing else, you know you've got a 50-50 chance of guessing the right answer if you couldn't find your mistake in the problem. Make sure you eliminate choices when you're solving multiple choice. That is one of the key strategies in solving multiple choice, is crossing off those obviously wrong answers. Not the ones you go, oh, well, I think so. No, it has to be obviously wrong. And you have to be able to say why it's wrong. Okay? And the summary. So the summary says, well, each linear equation is made up of two parts. What are these two parts? You can answer that question on your own. This has been lesson 4.5. Thank you for watching.